So we're going to step into our first panel discussion of the symposium, and this one is called Local and Global Circular-Based Solutions. So we're kicking it off today with a big picture look about all the intricacies that we've started to talk about already today on how we produce materials, consume materials, and ultimately are managing those items. So this panel is designed to help us think about all of those considerations that are at play when we work towards solutions. And today we want to have a thoughtful discussion about trade-offs, opportunities, and challenges that come with, with all of that and how we can design impactful policies, change consumption patterns, and determine management strategies, and how we implement new technologies. So we're going to discuss some of the short and long-term solutions and attempt to outline ways to navigate the plastic paradox. And in order to help us do that, we have this amazing panel that's going to walk us through this discussion. And the collective knowledge and the thought leadership on this panel is going to really blow you away. So I'm going to really briefly introduce them and then turn it over to them to walk us through this. Our first speaker is Nina Bellucci-Butler. She's the CEO of More Recycling, which is a mission-based research and information technology firm striving to harmonize human behavior with the natural world. Nina believes in delivering unbiased guidance and navigating the role that plastics play in the movement towards circular supply chains, valuing carbon, and reducing greenhouse gas emissions. Then we're going to hear from Scott Farling, who's the co-founder of Ocean Plastics Recovery Project. And Scott has dedicated his career to recovering value from waste. And after more than a decade of work in the chemical industry, he shifted his career focus on recovering value from complex waste streams. Scott's also served on the Oregon Green Schools Board, which is a nonprofit dedicated to engaging students through activities that advance understanding and ownership of sustainability. And so the last speaker probably needs no introduction to this group, and I can't provide one that will do her justice. But Bonnie Monteleone is the Executive Director and Director of Science, Research, and Academic Partnerships for Plastics Ocean Project and an adjunct instructor at UNCW. Bonnie has been studying and sampling ocean plastics all over the world since 2009 and has used this amazing skill set she has for communication and art to teach thousands about the impact of marine debris. Recently, Bonnie's been working with alternate energy companies, trying to study plastics to fuel. And so I'm going to turn it over to Nina, who's going to launch us into this discussion on circular-based solutions. Thanks, Nina.
Oh, unmute, please. Thanks.
Thanks. Let me share my screen. Let's see. Here we go. All right. Well, thank you guys so much. I'm really excited to be a part of this group and to share a panel with two people that I hold in so much regard. So I've kind of had this visual of like Scott holds this culmination of data and knowledge kind of on the West Coast, and Bonnie, and I've always had this like fantasy of how do we bridge more of the work that they do. So a little bit about our company. We're in a big transition. I think the whole world is in a big transition. So keep an eye on the image that's in the background of our logo, but we're at the core, not changing a whole lot, but we are changing the name of our company next month. But we're really focused on better data for better decisions. And we do that through research, facilitating core projects, and really developing web-based tools to bring to life the data to hopefully inspire people to take action, develop the smart policy, and innovate towards a circular, sustainable economy. So one thing that is
a picture.
Participants, please mute yourself. Thanks.
All right. So one thing that we've done over the years, and I've been doing this for 20 years, so I think particularly this year I'm having a existential bit of crisis of have I helped sort of hold up a house of cards by trying to facilitate so much plastic recycling, improving the system, one thing our company's done for over 10 years is track the amount of plastic collected for recycling in North America. And that's the data that's used by the EPA to determine the recycling rates. And as you can see in this chart, we were kind of steadily increasing that amount over the last, up until for about 11 years, we were seeing positive movement. We're starting to see that trend move downward. And as I took over the assets of the company, I purchased the company a few years ago, I started making investments to learn more of the issues upstream, to understand more of the global macroeconomic challenges as to how we address this dueling problem of both plastic waste and climate change. But to give a little insight, I think it's really important to have perspective. When we're looking at how much material goes into the curbside recycling stream, we're still dealing with the majority of material is fiber and paper. So just in practical terms, what the recycler at the collection and sorting level is dealing with is how to handle the huge volume of paper. And within the curbside stream only is about 5% plastic. And then when you look at total generation, it's actually, it's around, let's just round up to 100 billion pounds for North America. We're recycling between 5 and 6 billion pounds. And you can break it into these 4 major categories. So you've got your bottles, which the system is designed to do, to really go after within that curbside stream. But we're still not, I wouldn't consider hovering around a 30% recycling rate success. I definitely wouldn't pat my kids on the back if that's what they came home with their grades. And then the growing area of material is really in film and flexibles. And that has to do with, and really smaller format materials, because we're trying to be more efficient with our materials and lightweighting things so that we're consuming less fuel and natural gas. So we're going to be releasing the latest numbers in April. Last year, you can see we had some dips across 3 major categories. I'll hold the results for April, but some ups and some downs for the 2019 information. So this year and last year, we've had just a real increase in demand, particularly for virgin plastic, largely driven by the accelerated, the shift to more e-commerce across the board, whether it's entertainment, what we're purchasing, but also obviously medical and pharma with being in the middle of the pandemic. And a lot of the thought leaders are looking at, are we ever going to go back from being predominantly online, and just how much more packaging that requires? And it's not just the packaging, it's the entire Internet of Things that requires an incredible amount of plastic. And all of these materials have major challenges of getting post-consumer recycled content back into them. So bottom line is that we really need to manage things more from a carbon perspective, I would say, because we're seeing this both continued threat around our air quality and the greenhouse gas emissions, and then this dueling issue around plastic waste. So since COVID, we're finding much more plastic litter from PPE and other materials, and then just more being disposed of because of the concerns around handling material. Programs have been struggling, whether it's through the store drop-off programs or curbside programs. I think there's a bit more, has been a more of a license to go ahead and dispose. On the other hand, I would say from the motivated consumer, because we also have historically provided, we're kind of this, call us and we'll give you answers about the skinny on what's happening with plastic recycling. We're seeing a big surge. There's a real appetite for people that are wanting to do something to understand what their solutions are. And I just want to put this in this context of, from our ability to do so many things, whether it's the research that people like Scott and Bonnie do, or whether it's getting to the moon, communicating out of our atmosphere. All of these things are being here right now are really outside of what the natural boundary is. We're living like superhumans. And I was thinking about how fossil fuels, and by extension plastic, it's kind of the opposite of our kryptonite. This past week, I have not felt very superhuman. We had our kitchen gutted, so I was like missing some of those creature comforts. Our hot water heater went out, so I was taking cold showers, which I try to do because I know the Wim Hof, it's really good for you to take cold showers, but ugh. And then I had a broken foot, so I was hobbling around in this like boot, and I was thinking about all the ways that I'm trying not to buy anything, much less plastic, but we all are living in this very out of boundary, superhuman sort of way because of our access to oil and gas. So with this recent news, the plastic-free president, this letter for actions, presidential actions to address plastic waste. I wanted to raise this because it's very prescient right now. The new head of EPA, Reagan, has also been asked questions by different senators on, is this the level that we need to be looking at in terms of addressing these dueling problems of plastic waste and climate change? So I wanted to take a minute here just to, I don't know how to do the polling process here, but jot it down. I put these things down. What would be hardest for you to give up as you think about breaking free from plastic? So think about the plastic coating on all wires that enable us to have those hot showers or clean water, or the electronics and telecommunications that we're using right now, to the actual electronics, the phone, computer, earbuds. I was trying to put on clothing that isn't actually synthetic. And I was also thinking about when I first met Bonnie, it was on the expedition into the Atlantic Gyre, the Sargassum Sea, and that when we were getting ready to go out and snorkel in the Sargassum, they said, well, make sure you don't wear natural fibers, wear synthetic fibers. And I was like, okay. So we're really in the thick of it, but whether it's, keeping ourselves warm, bathing suits, I can't really imagine a bathing suit without synthetics, but also sports gear, metal equipment. So write down which one would be hardest for you to give up.
Please mute yourself. Thank you.
So here are the 8 actions that are in the presidential letter. And the one that really stood out to me is the advanced environmental justice in the petrochemical corridors. 2020 was a year of deep reckoning in terms of really exposing where we are with how we're handling the environment, how we're handling social justice, economic inequality. And as I try to peel back the onion on what is the real core issue that we need to be addressing to unlock this innovation and move into a more balanced circular economy, I think this one is really at the core. I always say we need a carbon policy, but we are living in such out of balance ways of doing business and conducting ourselves because we are okay with a lot of imbalance throughout the world. I think when we put this as a high priority, a lot of other issues will cascade out of that one. Okay, going back to some data and the perspective here. So we've done a lot of work with IHS Markit. They are an analytics company that tracks the petrochemical companies upstream. It's where in both speaking at that conference and listening and being involved in these studies, looking at the world analysis on global demand for both plastics, that's the petrochemical products, as well as refined products, which are your fossil fuels. There is continued global demand, and it's looking at how much the United States is producing and creating demand versus other economies and where the projected growth is. I had this sense of like just this massive tsunami coming upon us. And so if you layer these lines with what's the growth in demand for oil and gas, what is the growth in demand for plastics, particularly in other regions as other economies move into the way of life of the way a lot of Americans live, these 2 lines are important to look at in terms of trends. And this is where we have the complexity around the plastic paradox. We're seeing a leveling off of demand for refined products, for fossil fuels. And when I attended my first World Petrochemical Conference in 2018, I had this realization that as we have more electric vehicles, more use of plastic, lightweighting of things, there's actually been a drawdown in demand for oil and gas, and therefore a growth in production of plastic. So we've got this paradox that we're essentially dealing with. plastics account for about 50% of base chemicals and less than 10% of greenhouse gas emissions. So here is an overlay looking at it from generation of what we put into the municipal solid waste. So putting in perspective of how much is paper, board, and paper. So this is what's in the weight. This is total generation. How much is plastic? How much is organics? And so we need to think about, as we pull one lever, what lever we're pulling if we're using the same consumption patterns. This other article that came out in the last few months is that human-made materials now outweigh Earth's entire biomass. So if we produce 3.5 billion tons of waste every single day, and going back to that last slide of just what that breakout is, we are making choices about different materials, and each material choice and how we manage them has a very big impact. I was just thinking about, I went to the X Prize before in 2019, and it was all about the moonshot and just what as humans we're able to do. Again, superhuman, but is our moon shooting maybe overshooting Earth's carrying capacity? So I think it's pretty obvious we are living deeply out of balance, and we're not managing material that nature can't manage. So here's I'm really intrigued with the Drawdown project, because I think it was my time in grad school at Duke where my master's project was developing a decision tool to evaluate the trade-offs between using different materials in a specific application. And there's your knee-jerk reaction of what you think the best material is, but as you put weights on each of those criteria, and then you run the analysis as what you care most about. And for me, it's historically been, how do we really move to reducing our greenhouse gas emissions? We get into this really complex plastic paradox. So the greenhouse gas emissions from plastic is less than 10%. And we're getting, but food waste is much more. And we're throwing away roughly 30%. Now, Winnie Lau from the Pew Charitable Trust, when we were on the boat where I met Bonnie, she said, okay, so we obviously need to extend shelf life. We need to reduce food waste, but is packaging it in film so we can store up a bunch of steaks in the refrigerator the way to do it? Or do you just eat what you actually need and you get it? Now, there's a whole lot of equity issues within that and privilege issues within that, and what should we be eating? But just as we look around this donut chart, where are the biggest impact areas that we can reduce? And as we reduce one, are we drawing up another? So just really important to keep that in mind. So I think there's someone from Haiti here, but this is a video. It's actually a picture of a video that just was the most gut-wrenching thing that I think I've ever seen in my life. But after a big storm in Haiti, just how much plastic was being pulled into the streets and pushed out into the ocean. So these deep dueling challenges, the plastic paradox, greenhouse gas savings versus plastic waste. Okay, so go back to the question that you or the answer that you wrote down on which plastic. I was looking at just in my backyard, my older daughter here, just how much plastic is there from her boots to my compost bin to the trampoline. That's really one of their few outlets right now. But what do we do about the reusable and unrecyclable items, or the items deemed essential that have no feedstock or end-of-life solution? I think that this question, as we unpeel the onion, is requiring a radical paradigm shift. And we have to look at it through the fact that we're in this deep attention economy. We're in the fourth industrial revolution. We're in the information age. Everything in this era is about technology, and it stems from just how much access we have to oil and gas. So every time you do a Google search, that's a greenhouse gas emission activity. Every time you do a Google search. So going back to that poll, I don't know from a moderator perspective, should we have people add a few?
It looks like
in their answer.
We're about tied between B and E.
B and E. All right. let's go back real quick. There it is. The electronics and medical equipment. It's a tough question. Okay, so if, oh yeah, I had it in the next slide, sorry about that. So if we didn't have these, would we be so superhuman? Would we be able to live in this fourth industrial revolution? Or should we be looking at, I don't know, industrial revolution 8, where it's more circular, infinite? I don't know, but that's, I think, a bigger question that we need to recognize. So I'm really excited to, I'm going to turn this over shortly, not immediately, to Bonnie, because the research that she's doing on just looking at how much plastic is in the waste, what impact it has on human health, other researchers that are finding, whether it's plastic in placenta, a study out of Italy, plastic in our rain at the University of Utah. Who's responsible for pulling this body of data? I think that's another question, is it being done on the public level? Are we relying on these highly, motivated, passionate people to do this? And I also think we oscillate between what the individual can do and what the system is allowing us to do. So I wanted to go through, here's kind of a theoretical, if we were to move into a circular economy, here are the kind of dumbed down steps in terms of production, use, where it gets recycled, what happens to it, can it get back into the system? So right now we're currently subsidizing at least 20 billion pounds into fossil fuels. Globally, it's much more than that. And it depends if you include externalized costs. This is not including the externalized cost. On the other side of the equation, we have to dispose of material is a fraction of what it should cost if you consider the legacy impact of things. And in Europe, it costs more than twice as much to dispose. So we've made it artificially inexpensive to dispose, artificially cheap to extract, and therefore we have a really low recycling rate, and it often costs more to recycle than it does to use recycled or to use virgin material. So this is why I keep pulling it back to the global geopolitical question. It's because this is what fuels our American economy. We're based on consumption. Whoever has access to oil and gas is also who's enabled to be living in the most superhuman sort of way. So here's kind of the brass tacks. If we look at, and this is thanks to IHS Markit, that we were able to get the information on just the top largest virgin resin producers for the big category of olefins, so that's your polypropylene, polyethylene, compared to all of the reclaimers in North America. We've got less than, we've got a fraction of the capacity to handle that. So we're kind of at an overshoot day for recycling pretty early in the year. So even if we were wildly successful in getting everyone to do the right thing, what are we going to do to close that delta, given what I showed in terms of the market dynamics? So I listed out some of the things that I think have the potential to drive some change. This global plastic treaty, because we are functioning in a global environment, I think is really important. And what role can the United States play to lead that? How do we look at plastics in terms of being able to manage them? One approach, Canada's looking at a CEPA toxic approach, so categorizing plastics as toxins. There are always trade-offs and different approaches to these things. The EU is really taking a lead on requirements and putting the responsibility on producers. We've got the plastic pacts that are looking at roadmaps to really optimize the system and improve the whole life cycle impact of packaging. We've got Biden's climate plan, going back to toxins, the legislation in Europe with REACH. Minimum content is kind of a short stopgap type of measure. Deposit legislation, data is very compelling. PCR carbon credit trading comes with a host of challenges, but may need to work within a capitalistic system. How do we track these things? Blockchain. Well, as I said, the fact that we have every time you run a Google search, blockchain has an incredible greenhouse gas footprint, but we need that traceability so we can have the proper feedback loops. EPR, and then we'll hear more from Bonnie with the Blue New Deal and really leaning into natural capitalism. Bonnie's introduced me to this wonderful economist, and I love the convergence of science, art. You can see the painting from Bonnie behind me, and economics. And it's the convergence of that way of thinking that will shift us into this new paradigm, I think, really looking at how do we put the value on species and natural systems that for the service they provide to sustain life on Earth. So better science for better decision making. I want to turn it over to Scott Farling so he can share some of this insight with he's been educating me tremendously throughout the year. So I'm going to hand it over, and then I'm going to let Bonnie go, and then we'll come back together and talk through some solutions. So.
You're muted, Scott.
Thanks. I'm just pulling up the right slide here, or right screen. Okay, do you see a full screen view?
Now we do.
Yep.
Okay, great. I just need to move some stuff around here so I can see it. So what I'd like to do today is tell you a little bit about our organization, the Ocean Plastics Recovery Project, and then dig in to the research that we're focused on and how that relates to the circular economy. Sorry, I don't know why. There we go. So first, I think it's important to start by talking about how we got started. And it all comes back to Dr. Brianna Witteveen, who's seen here on the front of the skiff. She's a whale biologist out of University of Alaska, and introduced me to my partner, Andy Schroeder. Andy's been working in marine debris cleanup for about the last, I guess, 14 years now. And he did this initially through a nonprofit he founded, and had grown his collection operations. And over the last few years after National Sword hit, he really realized he was running into a problem. He had nowhere to really send his materials. He lives in an island community at Kodiak, and they have a landfill ban on ocean plastics and marine debris. And so what he was stuck with materials that he's pulling out of the environment, but he had nothing to do with them. And so that's what really got us thinking about what we could do together. So my background's in recycling and conversion technologies. And in the summer of 2018, we all met up in Alaska and started looking at some of the materials he's been collected, and realized that there's some value left in these materials. By the time I left, we had decided that we would partner and try to solve this problem using his skills in marine debris cleanup and my skills in the recycling sector. We also knew we'd need some partners. So we partnered with a handful of universities to focus on mechanical recycling research at Western Washington, chemical recycling research at Purdue, and pyrolysis and gasification or conversion technology research at Oregon State. And we've also partnered with a number of industry folks that have either unique technologies or are interested in pushing this work forward. Our mission is to continue the work that Andy's been doing and remove the ocean plastics from the natural environment, but also to add to that an effort to identify and develop reuse, recycling, and recovery techniques or solutions for these plastics, and then share what we learn with the global community. And we operate across these 4 core focus areas: collection, outreach, research, and education. I'm really going to focus in on the research piece today. I think the other pieces are important, especially the education part. When we got started, we saw this as an opportunity to get field research opportunities for our undergraduate and graduate student researchers, and get some high school students up into the Alaska wilderness and work on this project. But more and more, we're seeing some opportunities to use this environmental problem solving as a tool to pull people into the sciences and get engaged in solving these problems. And we're also seeing an opportunity to create a pipeline of undergraduates ready to go out into the workforce and work on recycling and recovery. So for research, we break it down into a handful of operations. There's the characterization or studying the materials themselves, pre-processing operations, basic research into the different technologies, mapping supply and demand, and applied research. So with any waste stream, it's important to know what you're working with. And so we spend a lot of time taking the materials that we've collected and sorting them. And the idea is to sort them for their best opportunity for recovery. So as you go from left to right on this chart, you can move into lower energy, more efficient recycling methods. And I'm going to get into that a little bit more down below. But an example would be as if you sort all the way to an injection grade, high density polyethylene, and then you further sort that by level of degradation, you can start to direct some of the materials to the lowest energy recycling methods like mechanical recycling, and then save the more degraded materials for more energy intensive recycling operations like chemical or conversion technologies. And so our basic research is looking to see what's possible with those different techniques. And then once we know what's possible, what's feasible from a process and economic standpoint. And then most important is what's best, what from an environmental standpoint and the impacts that these different solutions have, which one is the best solution for each individual category or fraction of that waste stream. This is some of the early work we were doing in Western Washington. This is Chris Owen. He joined us on one of our expeditions in 2019. And he was looking at recovering value from the blow molded HDPE containers. The next part of our research is really mapping out the supply and demand of ocean plastics. And why this is important is we can do all this research, but if we don't have a home to put these materials, we'll just continue putting them in a landfill and not take advantage of the value that's embodied in them. So what we want to do is we want to understand what materials we have available and what demand exists today and what other potential technologies are out there that could be a source of demand for these materials. And what we're trying to do here is identify those gaps that keep this material from getting back into the circular economy. So when we look at applied research, we're focusing, OPR really focuses on the left-hand side here, the collection, size reduction, sortation, separations. And we work with our university and industry partners once we get into things like formulation, recycling, and recovery. One example of this is a project we're doing at Western Washington right now to look at recovering plastics or resins from entangling debris. So this is some HDPE trawl net that we're working on. That's Juliana, Derek, and Bradley working on processing this material and taking it back to a resin pellet that we can then formulate from to get a good quality material to return to the market. So I'm going to shift now to the topic that I think we all came here for, which is the circular economy and how it applies to ocean plastics and really just materials in general. Talk real quick about the current state of the circular economy, advantages and limits of mechanical recycling, and then really these opportunities to develop a suite of potential solutions. So that's the what is possible piece. And then the economic and process considerations, which is what's feasible, and the environmental impact considerations. So in a perfect world, our circular economy might look something like this. But unfortunately with plastics right now, we're hovering down, like Nina said, less than 9% of plastics are returning back to the economy. And so that means that we continue to extract and we continue to discharge materials to the environment. And we can move this number up. That's not, 8.5 is not our ideal state, right? Mechanical recycling can solve a lot more problems. It's been demonstrated in other parts of the world that we could probably get this number up to at least 30%, possibly higher, but there are some real limitations. When we mechanically recycle plastics, if it's a very clean stream, like PET bottles, like natural HDPE milk jugs, those have a good opportunity to go back in at a very high level in the economy. They can go back to a bottle, they can go back into high-end parts because they're not burdened with a lot of additives and colorants and other materials. And they're not degraded typically. They've had a short life. The resin is pretty well intact. But as you start to have more degraded materials with lots of additives or colorants, you can't necessarily get it back into the supply chain perfectly. There's great opportunities to get it into applications, but we need other solutions. So that's where things like chemical recycling can come in handy to return materials higher up in the supply chain, or conversion technologies, which can again go back to virgin quality resins or can become feedstocks or fuels. All of these things can help to limit the extraction and limit the waste of materials. And so what I want to share is a few of the examples of things we're working on. This first one is the injection grade HDPE buckets. The picture I showed earlier, the ones on the left that were less degraded, we're working with our partners at Western Washington and Denton Plastics to create a product from that material and using mechanical recycling. And that's going to be the lowest energy. And this is what, as much as possible, we want to target these solutions where we're mechanically recycling, returning the materials. But as many of you probably are aware, when you go out and you collect ocean plastics, a lot of the material is a little more degraded. And so when we start to get into taking polyethylenes and oxidatively decomposing them and then converting them into another resin. So they take their materials and convert into high-end polyurethanes, which is an upgraded resin or higher value resin. If you guys aren't familiar with Novaloop, they're up until a few days ago were called BioSelection. So I'm sure many of you have heard that name before. But they've rebranded under Novaloop and are continuing their good work. And if you take a little bit more mixed stream of polyethylene and polypropylene and take it to a pyrolytic reactor, such as what Resynergy operates, now you can start getting materials that are a little bit more degraded, a little bit more mixed, and still giving them an opportunity to come back into the circular economy, either as a fuel, which is outside of the economy, or as a naphtha feedstock for refining, and then going back to polyethylene and polypropylene. And our last example is Enerchem, which is yet a higher energy process. It's gasification. They tack on to gasification, which typically produces syngas, which is used as an energy source. You can also go from the syngas through a Fischer-Tropsch process and go back into things like methanol and ethanol or ethylene and get back into resin production. What's nice about this is it again handles more complicated waste streams, things that would otherwise be going to landfill, but we're capturing the value of the materials. And so really what we're hoping to be able to do is show that with the suite of technologies, and not just for ocean plastics, I think this applies for all materials, but it's especially important for ocean plastics where we have more mixed materials, more degraded materials, more contaminated materials. We can start to take advantage of these solutions. We need to be mindful that as we move left across this chart, there's increasing energy requirements and increasing environmental impact. So we want to keep as close to we can as to the center and use mechanical engineering, mechanical recycling, and get these near virgin quality materials, or if we use a little more energy, get these virgin equivalent materials to go back into the economy. These solutions will help us draw down the landfill of materials and the need to extract more resources. That's what I've got for today. I'm going to pass it back over. I think, Bonnie, you're on mute.
Okay. Hello, everyone. And those were really two awesome presentations. And not only in the content, but the slides themselves are beautiful. So just to let you know, this is not going to be as pretty, but I promise to try to be as entertaining. So, take it from the top, Louis. So my presentation is going to be more on the work that Plastic Ocean Project has been doing at looking at the solutions, and one in particular, plastics to fuel. I'm going to go over some of the work that Plastic Ocean Project has done in the environment, and then what are proposed solutions that we've been dealing with, and then why we really need to steer this ship towards this circularity to answer these bigger issues. So we'll start with our research. So many of you know that I've actually done a lot of open ocean research. I've been to 4 of the 5 gyre circulation systems. And not to get into what that is, it's GYRE if you want to look it up. But basically looking for plastics in some of the most remote places on the planet. And after defending my thesis and being in those locations and just seeing how dire this situation is, I just decided to start a nonprofit. And so we do education through research, and I'll get into some of that, then outreach through art. So our artists, our writers, our videographers, they're the ones that can convey the message to the masses. So that's why they're a really important piece to solving this problem. And then solutions through collaboration. So that's where we're working with industry to either help them change what they're using or helps facilitate those who are trying to tread lighter on the planet. So basically, to sum it up in a nutshell, instead of giving you a bunch of statistics about how much plastic we found, it's basically we're turning the ocean into a plastic soup. And in fact, Charlie Moore would describe it more as getting chunky. When I went offshore with him from Hawaii to California, 30 days at sea, we were doing the 10-year resampling of plastics in the ocean, and the plastic pieces that we collected were much bigger than what he had saw 10 years before. So hence the soup is getting chunkier. So some of the work that I did while I was traveling around the world is also looking at what was washing up on beaches. We had a methodology for sampling beaches, looking for plastic particles. And we took that same model of research to Wrightsville Beach here in North Carolina. And my students would get so frustrated because they would be like, there's no microplastics. We're not finding microplastics. And so much like what we're learning is that every beach, every area has its own story when it comes to plastic waste and what's ending up in the environment. And on this particular beach, it's cigarette butts and styrofoam. So we started this work in 2012, and in 2013, Wrightsville Beach instituted a smoke-free beach, so banning smoking on Wrightsville Beach on the Strand. And what was beautiful about that is we had the preliminary data to see if the smoking ban was working. So we continued that work for 5 years. And then we found out that the Board of Aldermen were considering getting rid of the ban because sadly, cigarette filters or butts are the #1 thing that we find on that beach. So I had the students go through all of our data and quantify how many cigarette filters we found on the beach. And then we could clearly see that the first year, those numbers had dropped substantially. And then every year after that, they had been reduced. So we had the documentation to support that. And if we didn't have that, then there would have been no way of really determining if the smoking ban was working. The other beautiful aspect of that is the students got this opportunity to talk to legislators and then give them suggestions on how we could do better. And some of those suggestions were where the high concentration areas were. So we were finding them more around the piers as well as the parking lots. So they suggested better signage and then also emptying out the receptacles and maybe putting up more receptacles. And what's amazing is all of those things did go into effect. We still have our smoking or smoke-free beach, and all those have been instituted. So that is one of the true benefits of citizen science, as well as being able to do the work that we do. Other wonderful opportunities that we have had. So I'm now taking you from the middle of the ocean to the beach, and now we're getting into the watersheds. So we have been working with Duke Environmental Law and Policy, who developed a protocol for looking at debris lost or washed out into our watersheds. And not only were we looking at the types of debris, but also getting the names of those brands in order to help create some corporate responsibility. And so using this information, we present to students, and then we have them decide who they would like to contact and explain that we're finding your plastics in our watersheds and we need to work together in order to solve this problem. So really great way for us to not only determine how much waste is in our environment, but also getting young people involved in communicating with not only political leaders, but also with corporations. Another really wonderful, which I took these slides out, opportunity we have had most recently is working with Barbara Dahl at NC State, where we are looking at plastic particles about 1 millimeter or smaller in various watersheds around the Raleigh-Durham area. And it is really surprising that we're not finding anything bigger. So how are these very small particles ending up in this environment? And one suggestion, of course, is rain, right? So like these particles can be aromatic, and then when it rains, it comes down and washes it into these watersheds. So this is a gigantic problem, like beyond like simple little fixes and cures. We are going to have to do something extremely drastic, or as Blada would say, radical, to fix this problem. Another way that we are studying plastics in the environment is we received a NOAA grant with UNCW and Plastic Ocean Project and various others, where we were looking at the trophic transfer of legacy compounds, so DDTs and PCBs, and how they can work their way up the food web. So we were able to expose plastics to plankton, and in some cases, the plankton would prefer the plastics over their prey, which is pretty disturbing. And then we would expose the plankton to larval fish to see if they would eat the plastics or not eat the plankton that had ingested the plastics. And sadly, they didn't have a preference. They would eat the plastics and they would eat the plankton. And then we moved on to a commercially important fish, which is a black sea bass, exposed them to the plastics and the larval fish. And they were not as interested in the plastic, which is great, but they were eating the animals or the fish that were eating the plastics. So that way we could actually track some of the chemicals that we had associated to these plastics and see how they did work their way up the food web, though the actual fish did not eat the plastics. So this is an issue that is extremely near and dear to my heart. And I think we cannot just focus on the problem, but also focus on the solutions. So as I was doing this research for over the past 12 years, there have been a lot of solutions that were presented to us. And one of the first that was kind of new and creative was in 2011, Sun Chips came out with a biodegradable bag. And many of you might remember Jennifer O'Keefe. Her and I were buddies. In fact, she went offshore twice with me in the North Atlantic. And so when this bag came out, she was probably one of the first persons to buy it. And as soon as she was done with it, she stuck that bag in her compost in her backyard. And she kept a very close eye on it. And what she noticed was that the plastic was not composting. It was actually just breaking up faster. So the way they had built this biodegradability was to just have links in there that would dissolve, but the other portions were actually still plastic. And so that was a bit of a fail. Now, the other real problem with the Sun Chip, you may remember, is what? It was noisy. People hated the noise of this bag. So they actually changed it because of the noise that it made, which I find very funny. The other solution is compostable products. And so sounds great, but yet there's some other serious issues with that. One is, now are we going to go back to cutting down trees to make the cardboard? And then all of these products do have a level of petroleum product in there with the paraffin that they use to line this packaging. And then the third thing that they're adding is the PFOS, right? So in order to keep anything from saturating through the bottom, they're adding chemicals to reduce that. So now these PFOAs are actually ending up in compost. And then if you don't have a commercial compost in your area, then it really isn't any better than, sadly, the plastics. So some serious challenges with the natural solutions. How about some sci-fi solutions, right? So we've all heard about the engineering plastic eating bacteria, right? And I have so many people that will send me the link to this idea. And when I first heard about it, I was like, yeah, I like it. And then, you know, when you're watching a movie and they have like the person like look off in the distance and then they're like having a flashback, or they're like thinking something all the way through. And I started thinking this all the way through and I thought, ooh, so plastic was never intended to end up in the ocean. So this bacteria is probably not intended to get out in the environment, but it will. And then the problem with bacteria is it mutates. So like maybe not straight away, but maybe over time it's going to mutate. And then is it going to be like a form of rust for our plastic bumper, or eat the wiring casings, or even worse, and this is when I had the moment of like, no, was, what would it do to whale blubber? What could it possibly do to animals out in the environment? And so I think before we take that path, we think long and hard, because how would we ever fix that problem once that got out of control? And then the other, of course, is chemical recycling. And that's something that I'm going to go into considerably. So plastic recycling has been having its challenges. So one being that in the 70s, when we didn't have anything in place, and in fact, Earth Day was part of shedding light on this stuff called plastic that didn't biodegrade, that was filling up our landfills and causing a lot of financial as well as environmental issues. So in the mid 80s, the plastics industry came up with an idea. They said, let's call it recycling, right? So they put the chasing arrows on the bottom of almost every type of plastics. What they didn't tell the public was that they really hadn't figured out how to recycle most of those plastics. So what we have, and mostly today, are 1s and 2s that are recycled. But if your 1 is a to-go container, you might as well throw it in the garbage because it's also based on shape. So there's a lot of issues with recycling today. And the other conundrum that we're facing is the fact that we have pushed people so far away from the idea that plastic is good that we have completely demonized it. And this is where I'm being radical, because I'm going to call out the plastics industry for not jumping on board with this recycling as they had started to in the 80s. So imagine if in the 80s they were really getting behind the notion of what they presented as the solution, we might not be having this conversation today. But because they didn't, we are now at this incredible crossroads where we have Break Free from Plastic Act on the table to chop off any more use of plastics, as well as even chemical recycling. So they're basically poo-pooing the idea of what we can do with plastics, either turning it back into plastics or turning it into fuel. So my question to Plastic Free is this. You can't just, shut off the pump. You've got to do it gradually. You've got to create change. And as my kids used to call an old phone a brick, right? So we didn't go from the beautiful phones that we have now from where we were when we were carrying around these big clunky phones or our car phones, right? We had to gradually create the change, and it was based on desire. We wanted better. And so we have to instill that demand for better, but we may not get there straight away. So what do we do with the plastic that's already here? And what are we going to do with the plastics that's going to continue to be produced over time until we put some of these better practices into place? And so that's when we started thinking about plastics to fuel. So out of all the options that were out there, we were thinking, well, if you turn it into fuel, it's gone, right? We don't have to worry about it leaching any more chemicals. We don't have to worry about it getting in the stomachs of fish. We don't have to worry about it entangling animals. And we are actually able to produce a product that is still needed today until we completely move away from fossil fuels. And this is where that clunky phone idea comes into play, is as we move towards electric cars, like Nina said, we probably are going to move more towards plastics for that industry. And in fact, I was able to borrow an electric car from Jeff Gordon Chevrolet. So they want us to drive these cars around and promote them. And I went to put my plastic ocean project magnets on the door, right? And it didn't stick. And that's because there's no metal. It's all plastic, every bit of it on the outside. So that's what makes it lightweight, and that's what's making electric cars more feasible. So then how do we take right now the situation where most of us are still using gasoline and fuels in our cars? How do we take the problem of today and turn it into something that we can at least use and get rid of it? So here we have my version of Emmett Brown, and y'all might remember Dr. Emmett Brown from Back to the Future, where he takes a banana peel and puts it in his flux capacitor, and he's able to make energy in order to fly his car, right? So this was the same kind of idea. It's like this is kind of the Back to the Future solution that we have to consider to embrace. And truthfully, this probably could have been done decades ago. Again, here's an industry. I mean, look at this incredible infrastructure that's put in place for us to have fuel. It's absolutely space age looking. And yet we are told that we can't do plastics to fuel. I dare dicker that response. And so what we've been using is just a tabletop reactor, something that we could emulate the work that's being done by Renewology, but to actually research some of the stuff that they're doing. And basically all we're doing is what industry does, and that's distilling the plastics. So we're re-refining the plastics into fuel. And basically what they're doing is they're taking crude oil out of the ocean, and then they take it to a refinery where it's exposed to high pressure and heat. And then it turns into a gas, and then they cool it into liquids, and then those liquids will separate by weight and density of the particular petroleum products. So what Renewology is saying is that they can do the same thing, and there's some real benefits to the fact that one of the gases that's released from melting plastic is methane, but you capture that methane in order to use that as your energy source to melt the plastics. So you're really trying to utilize all the resources that can be delivered through plastics to fuel. One of the byproducts is wax, and so that's something that you can certainly turn plastics into. And also there's a residue or a char, and we've even been playing around with the char. As it is activated char, you can actually filter water with it. So that's another avenue that we could go down using the plastics to fuel. But they're basically saying that they could recover 70 to 85% of fuel from the plastics they put in their system. So here are some of the other claims that they made. So they're taking a zero waste product and turning it into a commodity. They are using the methane as the energy source. There's zero emissions. And when you combust it, there's less pollutants, there's less sulfur content. As I've mentioned, about up to 80% of the plastics turns into fuel. So what we decided to do was try to look at all of the things that they said this plastics to fuel could do. Because one of the things we didn't want to do is just jump on the bandwagon that yes, this is a good solution, that we wanted to look at it from every aspect that we possibly could in order to determine if this was a viable solution. Now, what you don't see on this list is dioxins. And that's because you can't get dioxins when you do plastics to fuel. At least that is our understanding. The report that was put out by the Break Free from Plastic group is that they're lumping the plastics to fuel in with incineration. And so we're challenging that because one of their claims is that it produces dioxins. And so that's one area that we need to add now to the research that we're doing. So basically we're characterizing these fuels using NMR and GC mass spec. And we're taking the different types of plastics or subjecting them to variations of temperatures to see, you know, what temperatures produce the best products, what temperatures would produce the paraffin, and using different types of plastics. So stuff that we've collected out of the beach, stuff that we collected in the ocean, and then just household waste. And so I'm not going to go over all of the list of these different aspects of it, but basically what we discovered was that there's really two plastic types that work best, and they're the olefins. So the polyethylene and the polypropylene are the best for producing fuels. And you can put in about up to 20% of polystyrene. And polystyrene does add some benefit. In fact, I've heard in some cases that is a chemical compound that is added to fuel to make it more combustible. We did back check to see how much fuel that we were getting from the plastics, and it was quite impressive that sometimes it was even over 80%. So I also had two business majors working on this project as well. So while I have chemistry majors working on this project, I also have students that are looking at the results from this research. And then what they did was go back to Renewalogy and make some suggestions. So one of their suggestion was, you know, maybe instead of making fuel, you could target paraffin. We have 16 candle companies in North Carolina. So imagine if you were taking plastics and turning it into paraffin. And then another suggestion the students made is, instead of trying to make these gigantic, you know, 10-ton reactors, could you downsize them so that you can control better what's going through the processor, and maybe take it to island nations where people could really use the fuel much more so than other parts of the world. We also looked at byproducts. So again, using a lot of high-end instrumentation to see what kind of byproducts we were finding in the fuel. So polycyclic aromatic hydrocarbons, or PAHs, are one of them, and they're not good. Benzene, toluene, ethanol, or ethyl benzene, and xylene are also not great chemicals to find in your sample, but they are also found in fuel. So really what we're learning is this stuff is basically toxic, this plastic. And so when you turn it into fuel, it's turning it into what fuel is, and that also has toxicity. But the real take home was that in comparing the byproducts to fuel at the pump, that it did relate very closely to what we could buy at the pump. Sulfur content. This was one of the big issues that we wanted to look at with the plastics to fuel. So sulfur emissions are a terrible pollutant. And so we wanted to see if it was true. So Renewalogy was making the claim that there was less sulfur in the plastics fuel than in bunker fuel or other types of fuel, and even fuel at the pump. So that's what we started to do. We did two things to look at this. So one was we had to send it out to a lab down in Texas. This lab specializes specifically in looking at fuels. So we sent down the fuels and the different types of plastics that we made the fuels out of. And then we also combusted the fuel, put it through a charcoal filter, and then we sent the filters as well as a blank down with our samples. When we got the results back, we were shocked to find that the emissions through our filter were actually lower than the blank that we sent. So in other words, there was sulfur actually in the filter before we even used it. So we can guess that there's not a lot in it because it blew out what was in there and actually lowered the amount of sulfur in the filter. So that's inconclusive work, and we have to circle back to that. But what we did learn, so our hypothesis was correct, because they do add sulfur to make black plastics. And then the other thing that we were quite surprised about was that there was elevated sulfur in our ocean plastics. And so that just gives us another road to have to go down to look at how is that sulfur ending up in these plastics? So is it sulfur in the water that these plastics are adsorbing? Or is it the biota that grows on the plastics that's actually also increasing the sulfur content? And then we were pleased to find that our mixed plastics had low levels, as well as the pre-production, which naturally you would assume had low levels of sulfur because there weren't any color additives or chemicals added to the pre-production plastics. Sorry, I can't see my last point here. I think the most important take home is that all of these products were below the accepted level of sulfur content. So when we start thinking in terms of turning plastics into fuel, we aren't really increasing any harmful effects on that level. And then also we looked at the quality of our plastics to fuel to commercial fuels. So we looked at several: diesel, gasoline, jet fuel, and kerosene. And again, we were finding the same things that we find in the commercial fuels that we found in our plastics to fuel. And so I've shared with you a couple of posters throughout my presentation. And if you're interested in looking at any of them, you can find them on plasticoceanproject.org/research. And there's a whole lot more posters that will address the plastics to fuel work. So we do need to do more research. And this is what I mentioned as far as the dioxins. But really, as the other presenters have brought out, that it's not going to be one solution. You know, plastic has been wonderful at satisfying a lot of solutions to problems that we were having, especially in the medical field. But so we have to figure out what solutions fit the right problem. And that's where we're seeing that this plastics to fuel would probably work best for islands. So when you think about, you know, islands have to have fuel shipped there, right? So there's the carbon footprint for that. There's the risk factor, the volume of single-use plastics for tourism, or as Blada was sharing with us, just how much packaging is shipped to Haiti. And then a lot of the debris that washes up on their beaches, right? So if we could take this technology and figure out a way to put maybe smaller facilities or even portable facilities so that we could work with people like Matt Coyle, who's coming up with this solar water, using solar energy to purify water so that we don't have to send so many water bottles whenever there's a disaster. And maybe we could include the plastics to fuel, because one of the most challenging things, especially after a hurricane, we know that here in Wilmington, that access to fuel, it becomes much more challenging. So imagine if we could pick up all the trash, or at least the ones that we want to target, and turn it into fuel so that we can have some emergency relief along those lines. And then I'm going to switch out real quick to share one more thing. You got to move your pretty faces, okay? Bear with me. Okay, it's right here. So, can you see my screen? Yeah, okay. So with all that said, what we really need is to get our legislators behind the future. And as you can see, Biden is doing an incredible job. He's starting to listen to those things that need to be done. He's starting to instill some of the original concepts of the New Deal. And so we're actually encouraging him to think about the Blue New Deal. And there's many reasons why we need to do this. And just looking at the plastics alone, there is so much we could do in order to increase our even the collection of plastics. So one is having the bottle bill in all 50 states. I mean, this is incredible that we don't do that. We know that the plastic bottles and the shampoo bottles, the laundry detergent, those have the most value. So why aren't we collecting them? And then by doing so, how do we get those recycling industries back to our country? Because before 1980, or I guess it was after 1985, we used to have 300 facilities that were taking plastics and turning them into pellets where they could be sold and used as well as pre-production pellets or virgin plastics. So let's bring back that industry, and how we're going to do that is we have to subsidize it. So we're asking our government to take some of the subsidies that are given to the oil and gas industry. And I think, Nina, you said something about $20 billion. According to the Center for International Environmental Law, they suspect that it's closer to $85 billion. So not to take the subsidies away from the industry, but to have mandate that we have some of the funding go to the back end of this problem. And how we can do that is facilitate some of the new and upcoming recycling facilities that can then utilize these plastics instead of competing so heavily with virgin plastics. And with that, I will. Thank you.
Bonnie, were you wanting to show a slide for Blue New Deal? Because it was your last slide.
Oh, darn it. Yes, I did. All right. I'm still a rookie at this and I don't know why. Okay, share screen. Let me see if I can get it. Okay, quick look. Here we go. Yeah, so the Blue New Deal and just basically to how we can solve this problem. So I can make this available as well, but just the economic opportunities as well as the negative externalities. So. Basically what I just said.
All right, Heather, would you like to open it up for Q&A, or do you want me to kind of close out a couple more slides? How would you like to?
Totally up to you. We do have some questions in the queue, but if you want to pull together that and summarize first, that's cool too, or we can do it after Q&A. You let me know.
Okay, I'll do a quick, let's see, here it is. All right, so we wanted to go ahead and just, after hearing the Ocean Plastic Recovery Project, so we're looking at, and Scott, one thing I wanted you to also mention is, do you want to talk about the Kodiak Island element with Bonnie raising, if we have baseline data and we are implementing these different solutions, how are we measuring against that? Do you want to kind of give another little plug on that?
Yeah, I can real quickly talk about it. I have a slide, but it'll take me a few minutes to pull it up. But we have been working on putting together a project to look at one specific catcher island up in the Gulf of Alaska that would be reasonable to clean within a season. And going and conducting a baseline study where we go in and clean up the entire island, remove the marine debris, characterize it, also look at the impacts of, we're usually dealing with more of the macro plastics, but also look into the soils and do some of the work like what Bonnie does and focus on what's been breaking down and getting into the environment. And then having that baseline data as here we are in 2021 or 2022, and start going back every year and re-cleaning the beaches to see what's accumulated in that each year's time, and try to hopefully, ideally what we would see is a drop in material over time as solutions start to get put in place around the world to prevent ocean plastics in the first place. And
why is that island in particular? I think that's
that island in particular is, it's situated to really capture a lot of materials. If you think of like the ocean cleanup device, the passive collection system, that's what this island serves as, a passive collector of ocean plastics. In 2015, my partner and another group, the Gulf of Alaska Keepers, went there to clean it up with some funding from Japan after the tsunami, and they removed 220 tons of material off of this one island, and so it just works as a good baseline study. It's completely remote. There's one inhabitant, which is the person that tends the lighthouse, and it's fully, all of the impacts are coming from abroad or from the ocean. So.
Okay, so I just wanted to add in a few other beyond Ocean Plastic Recovery Project, Plastic Ocean Project, since we're virtual, but still steeped in North Carolina, I just wanted to also put a plug in for our Office of Research and Development, EPA, in conjunction with a team of scientists around the world, some Danish scientists, NC State, and the Research Triangle International have developed a tool with a lot of potential, I think, that takes into account all of the human health environmental impacts of how, based on population, how do you invest in the infrastructure to recover all materials, not just plastic, given all the different trade-offs. And it's the MSW decision support tool. There's also a lot of other activities. This is not exhaustive, but Resource, the WWF has a tool that's trying to establish a baseline of how much plastic different companies are using, so we can look at how the progress we're making. The US Plastic Pact is adding another layer onto that, as they have their very important goals around increasing recycled content, increasing the recycling rate, eliminating unnecessary materials. And then we have, looking upstream, how do we design for recyclability, really hearing from those reclaimers that are actually dealing with that material. I think their voice has not been, we haven't listened to it quite as much, and just how we're bringing more of the collaboration together. The cruise ship that even though I live in North Carolina, it took getting out into the Atlantic Ocean to meet Bonnie, but the Soul Buffalo Ocean Leadership Network, I think, is bringing together kind of the tension of the opposites, those with different camps, so that we can really move into this, new space of merging how we address economics and the science of this issue. And then we have the tools that we've been developing over the years to provide more transparency and to make the connections in the marketplace. We have put all of these together as we've been transitioning ourselves as a company to making more of the data available, and very committed to it being publicly available, not a pay-to-play, keeping it free. We have the information exchange that I hope to bring in, the decision support tool, but it's basically a map and directory of different market development activities and policy, and hopefully there will be more smart policy across the country. We have plastic markets. That's where you go find markets for unprocessed material or supplies of post-consumer resin. We have a biorecycled products directory, so giving support to those companies that are actually using recycled content, and all of that's available through one platform, circularityinaction.org. And I really think this is we get into camps as we address these really existential crisis type problems. And we are going to have to drive the next era of business of true collaboration. My team has been leading a group of brand companies in the US and in Europe on really defining this, taking one packaging format, not because I'm in love with the squeeze tube, but because it was this one that was very ambiguous in terms of, is it considered recyclable or is it not? And as we took that kind of simple question with a group of companies that really want to find the responsible way to get a claim of recyclability, what having the national sword exposed is that just relying on access as our definition of recyclability doesn't quite go far enough. And so we fleshed out this whole decision tree to look at what makes it technically recyclable. But the holy grail is really moving into, is it a circuit? Does it have, what's the circularity quotient essentially? So what is the full life cycle impact? What is the recycled content of it? With using recycled content, you have like almost a 90% energy savings compared to virgin. Does it flow through the existing infrastructure? Are enough of that particular format compatible? Have we moved the market share? So we've done this exhaustive study to flesh this kind of roadmap out, and then working to harmonize the lessons learned across different regions around the world. And as I mentioned, Circularity in Action, this is what we're going to be pushing more into this year is, here's the path to circularity, and where are you in that path? And how do you connect to the tools that you need? And it's not just our tools, but it's really a directory of tools to support companies, individuals, and decision makers on the path to circularity. And we're going to be expanding this as we try to tackle these are complex and charged topics sometimes when we define what is chemical recycling. Is it monomer recycling? Does it have more environmental risk or benefit? How do we recognize with transparency those companies that are really leading into this space? How do we make decision tools for the general public so that it's not an optics thing or based on what some celebrity says is the green thing, but where's the science behind it? So this is what we're going to be expanding and looking for partners to move forward. So in terms of solutions, and the 3 pillars that we talked about as a team when we developed Circularity in Action is better policy based on science, innovation, how do we unlock that innovation? And that comes back to an economic policy. And how do we mobilize the general public and to open up all these trade-offs around greenhouse gas, toxicity, water consumption. But there's some really basic actions for circularity that we're going to be trying to build a stronger movement around. It's less and local whenever possible. Really supporting this public research, creating the incentives to reuse and encourage companies to design for reuse and durability, just picking up litter. I mean, that's when I go on a run, I'm amazed with just how much is in the woods around Chapel Hill here. Recycling right, we have some tools that it's, most people still don't know that while we can remember a reusable bag at the grocery store, there's things like bathroom tissue overwrap. I mean, I'm hoping to get a bidet, but we still have this bathroom tissue and the overwrap. What do you do with it? And then really trying to buy recycled and support those companies that are designing for total recovery. So I'm going to go ahead and share, we're not launched yet, but our new company name is Stina. And I really believe that the potential for innovation through inspiration with nature is as great of a risk if we ignore nature signals. We have to really unlock the innovation and through inspiration, I think, from nature to get back into balance. So I look forward to working with more of you as we proceed. I look forward to questions.
Okay, awesome. So I think there's a couple of questions that are sort of falling in line with sort of the technology piece. So I think I'll start with there, but and the innovation piece that Nina was just referencing. So are any of these systems scalable and maybe scalable down so that they can remain efficient and be deployed to solve problems kind of, Bonnie, I think you were referring to this maybe on an island or, something along these lines. So how scalable are some of these things right now? And what's the forecast for scalability and implementation?
I thought Scott should lead, but what we're learning is that I think we jumped into it too fast. So there were a lot of people hopping on this idea of plastics to fuel. They were buying their technology from China. And then when they would get their components, they wouldn't fit. I mean, when you're talking about high heat and pressure, all the fittings have to be on point. And so there were a lot of failures based on just the construction. And the difference with Renewlogy is they make everything in-house. So they do not outsource other than maybe some local welders and such, but they make everything in-house. So all of their fittings are secure in order to make the process work properly. Because if you don't have that, then you're just going to have problems. And so several of them maybe got investors and therefore they needed to make money straight away. And so they failed because this system wasn't working properly. And I think Scott could probably address more about that side of it, but that is what we learned from the research that we have done. And the other side of it too is that, when you're starting something new, you want everybody to win, right? Like you want your competitors to be successful because you're trying to prove a point. And so when they fail, it actually weakens the credibility of such technology. And I think we've been experiencing some of that as well. Scott, what do you got to say?
Yeah, I agree with what you said, Bonnie. And I think there's a couple of things. First, there's a lot of work that goes into some of these technologies. It's not it's not like you just jam some waste in and you make a product. It's a lot of work on the upfront side to understand the feedstocks and what the specifications of the materials are and how you prepare a feedstock to actually make a useful product. As far as scalability, they certainly scale up well, and you get the benefits of economies of scale. I know some companies that are already showing some really good success are Plastic Energy over in Europe, where they're creating a naphtha product that's going back into making virgin equivalent resins out of waste. There are some folks that are working on a smaller scale. I know Renewlogy has a smaller scale system available. We've been doing some work with Resynergy, which is a microwave pyrolysis technology out of California. Their base system is about 1 ton per day and can scale up. They think they'll probably scale to as much as 20 tons a day. And you do need, for me, the idea is you need a system that can operate safely and not require a lot of manual operations, so that it can operate and produces fuel and continue to be used if you do deploy it in more remote regions. But certainly I think there's a great opportunity for the systems.
Yeah, I was thinking about with any manufacturing, you have to have supply, demand, technology, and investment, just whether it's recycling or anything else. And we've been approached by a lot of companies, both traditional petrochemical companies and those that are looking to get into the market. And the biggest question is, but how are we going to find the supply? And so I think we've got a bit of a coming to, a reckoning around, we've been sort of letting go some of our collection systems or moving towards a more single stream, but this is not the panacea to make it really, just let us off the hook. So building those supply channels in a very efficient way where we continue to segregate material will make it more economical and therefore also more environmental as we look to scale up. In working with IHS, one of the big pushes, and I'm kind of splitting logic here because I think that it's very attractive to think about how we do small scale, and particularly for island nations. And so how do we make it economically viable for that? And also how do we make it the investment to kind of unlock so that petrochemical companies transition into this vertical integration? Until they're really embedded in that, I think we're going to still be chasing this tsunami with this trickle of recycling. So, it's looking at where are there already assets, basically. And my fantasy is that we apply the amount of research and support from the Department of Energy in looking at how we revolutionize extraction with the whole shale gas revolution, applying that type of research to understanding the entire landscape of where material is generated and where there are current assets, and matching up, do a full gap analysis so we make the investments into the technology in the appropriate locations, given all the trade-offs, with the backdrop of what the presidential action letter says, that we have to do it with the cognizance of, are we putting more burden on certain communities? I just think there's tremendous opportunity between what the Office of Research and Development has, the potential with the Department of Energy, and the institutions across the country, from MIT's work right now to Lawrence Berkeley Lab, and then labs such as Scott and Bonnie. Pulling this data together, we can have, I think, a truly optimized recovery system. And the fact that you can think about something and almost get it that day from Amazon, we should be able to figure out reverse logistics. It's not a moonshot. It's just whether or not the economics are in place to do it.
Yeah, we might need Chick-fil-A to come in here and tell us how to do some logistics. They're good. So, Nita, that was kind of what you were just commenting on, was kind of building on something I was thinking about while you were talking. And that's sort of something that we see sometimes in the recovery and recycling industry, where it's, it's sort of this chicken and egg conversation about, what's the supply and what's the investment on the other side to recover and process these type of materials, if it's sort of like a, shaky supply or hard to get at supply, or, not that it's not there, but maybe it's a little bit harder to get at. So I'm curious if you've heard of any conversations or had any conversations that sort of walk that balance between investing in the new technologies that can recover this, and sort of the, are we shifting away from plastics at all? And is there that conversation happening about why would we pursue this if we're going to move away from plastics, fossil fuels, all this?
Yeah, it's when I testified before Congress, my point was like, the perspective of working in Europe was really important for me, because one of the leaders in a petrochemical company said, as Borealis, we're like, how do you achieve goals if you have no levers to pull, if you have no policy? And this is coming from a petrochemical company. And if we don't have a North Star so that companies can innovate towards what we all want, then we have conflicting goals and objectives, and it's left up to just pure optics. So I think that, and this is why I was excited to work on the second study with IHS. The intent of this study, it's like a 600-page document at this point, but it's at what point does what does the value of carbon need to be to shift petrochemical companies from being in what's called the rivalry stage, so competing with, how much demands are going to be from PCR, how much is going to be eliminated or substituted, to when does it make sense for companies to invest because there's an economic reason to. And Bonnie has a similar passion to my business partner, Stacy, which is we need this ultimate roadmap. What's going to be eliminated, what can be substituted, and what's still going to be left, and how do we best manage what's left? But we have to have that North Star policy first. And we're working with WWF on some of this right now. And I think the US Plastic Pact and the pacts at large can play a really important role, but it's a political sticky widget to tell someone their product is not essential. So we need scientists to help us define what that true roadmap and trade-off is.
And then, so this question was posed to Scott, but I think, some of the other panelists might be able to weigh on this too, but do you think that advanced conversion or chemical recycling for the most degraded streams of plastic is highly preferable to sorting the items for waste to energy? And if so, why?
Yeah, I think when you have the opportunity to return it back into the economy as a material, I think there's a benefit there. Waste to energy, I think, can be a tool, especially in the near term, because we have that available today. But being able to take these materials, break them down to their building blocks and rebuild them into the materials that they once were, or something similar, I think is a great use of what we have already invested in the materials.
Save the molecule.
Yeah, exactly.
Bonnie, you want to add anything on that? Or you just
yeah, I don't have much to say about it. I think like I had pointed out, people are like really hating on plastic, right? But as Nina will say, like, look at yourself. Like right now, look at yourself. Look at the fabric you're wearing. I mean, look at your shoes, look at your glasses, like it's not as simple as just saying we don't want it anymore. We really have to be thoughtful on what stays and what goes, and so what's going to be turned back into recycling. I think Scott said yesterday when we had our meeting, is like, if you could visualize, like if we just could keep recycling the plastics, we wouldn't need any more fossil fuels to go get more, or at least we could slow it down to a drip. So I think it's all very promising. I don't think we should poo-poo any of it. I do think we need to reduce our use of anything and everything. Like that has to be number one. The US generates more waste than any other country in the world. We're not even the largest by a stretch. And so we really, us Americans, need to start making up our minds that we need to be as big a part of the solution as any other country. We can no longer point our finger that China's doing it, or, all the plastics in the ocean because of 6 rivers in Asia. Most of that trash actually came from developed nations. And so we are the ones that are driving this. As I like to say, it's in our hands, literally. So let's stop using so much of it, and then let's figure out what stays and what goes.
Yeah, and if I could add to that, I think what Bonnie said is really important. It's all materials. It's not just plastics, and it always worries me when the topic is how do we get away from plastics? Because are we considering the environmental impacts of switching to alternative materials, and are they being measured and understood to a level that we know that we're moving in the right direction, or are we just making an emotional response to go away from plastics into a material that might have worse upstream environmental impacts?
Yeah, so when we're talking about roadmaps to decisions and all of these conversations that have to happen around products, it's like, how do we do that? So how do we look at what materials are out there? And, this is just one example, but it's probably a good representative one. About Colgate just came out with a new toothbrush, and they sell something like 30% of all the toothbrushes worldwide. And it's a aluminum bottom and a replaceable plastic head. So it's reduced the amount of plastic in this toothbrush by 80% or something like that. So, so that sounds awesome, right? It sounds like a good thing. And everyone, you could probably look at other products, but, so number one, as we look to the roadmap for all these different products we have, how do we make these decisions about what should stay as plastic? How does that make sense? What should move away from it? And then, Nita, from a brand owner perspective, like, how are we engaging brand owners in this conversation as well? As they're sort of facing more pressure from consumers around switching to, better packaging and how they're making those decisions, so we don't end up with alternatives like Scott was mentioning that might not be better.
Well, this is what I think we need to lean deeply into to develop this quotient for circularity and have the transparency that's required. I think one of the big nuggets right now, or the nut to crack, is how we are going to track and verify what is the standard for verification of recycled content. That work is there's not an easy answer to that. There's a company called Eunomia that we've worked with that's more European based. They're providing guidance to the European Commission on this. It's a 1.5 year long study, so it'll be interesting to hear what they determine. And I personally don't have an opinion on it yet, because while there's a host of problems with trading credits for recycled content, there's also the potential to have that money move down into those who actually handle it. But there's so much opportunity for fraud within that. There's the opportunity of, do we apply a mass balance approach so that those companies that can have long-term offtake agreements to source PCR from chemical recycling to stimulate the investment in that? Well, that also becomes right for, is there actually recycled content, or have you averaged it across your company products? And just to apply it for a more strict policy, say in Germany with higher recycled content requirements than say, North Carolina. So I think there's a lot of issues, but we've got to define what that North Star is and be really transparent about the decisions that we're making. And I think it's going to require some both government and private sector engagement to define what that roadmap is. I don't yet personally have it, but it's what I am looking forward to working on. Someone asked the question, what would have to be in place to handle a bottle bill? It would be ideal to have one national bottle bill because of the challenge for companies to manage how they comply with every system across different states. And there's issues of material moving back and forth across state borders. So those states that don't have a bottle bill end up with sometimes higher recycling rates because people are bringing it in. But there are great examples looking at the Oregon bottle bill, as well as the BC model. And ideally, you have the complementary policies of a bottle bill with minimum recycled content in the overarching structure of EPR that includes what's called eco-modulation. California's bottle bill has the kind of closest to an eco-modulation approach in that if you bottle something that has a low recycling rate that's difficult to recycle in this system, you have to pay a higher per unit fee outside of just the deposit. So it has some built-in natural drivers, economic drivers to do the right thing. There's a lot of other challenges with the California bottle bill, but we can overcome the challenges that are often stated of you're stealing the value from the MRF. You know, there's tons of reasons that have been given, but the data is compelling, and the Container Recycling Institute has a lot of that data. So I think should be one of the top policy tools that we deploy. But I also think we need to not get stuck in that one. Sometimes we penalize the product that has the largest, PET bottles is the most mature in terms of a material type. And the most sought after commodity right now, HDP Natural is selling for just the baled, unprocessed material way above virgin pricing right now. And the reason, it's just supply and demand. We have less and less. Think about how much milk you've bought recently in a traditional plastic milk jug. So as people move away from to non-dairy milk or to colored resin for that, that supply is shrinking, and we're more and more dependent on that one specific feedstock to meet these recycled content requirements that can be food grade, because food grade is based on, where the supply of material is. It's already designed to be food grade. It's a very light material, so you can get the closest to near virgin. It takes more energy to do it, but when you start moving outside of that specific commodity, you open up a whole host of challenges in terms of, do you know what other chemicals may be carrying with it? And that's one of the challenges we have in the US, particularly compared to Europe, where there's more oversight on chemicals in the environment.
Right, it's sometimes dizzying about how fast new types of packaging come out, and we're trying to design solutions, and then there's new things that are on the market, and so I'm sure that's a big challenge as well.
Stuart also said that ACC developed a roadmap to reuse. He's going to touch on that in the panel tomorrow. And the Recycling Partnership and other associations have developed similar plans. The overall effort is aimed at federal policy to support an upgrade to US recycling system and move us closer to a circular system for packaging. So yeah, I have I feel a lot more optimism when organizations are leaning into EPR, extended producer responsibility. I've heard from major converters, the companies that make the product for brand companies, that they recognize they can't do what they need to do if there's not a level playing field, essentially.
Right.
Bonnie, a couple of questions for you that came up throughout the presentation. Number one, why is the soup getting chunkier?
Well, that is a very good question. And it just might mean that more of it's ending up in the center of the gyre that are in bigger pieces. There's really no explanation, but the number of particles went down, but the size fraction went up. So more research.
And there may be, a lot of plastic recycling is basically, and Scott can speak to this in much more depth than I can, but you're basically looking at what floats versus what sinks. That's how you separate some of the major categories. So how much of what's floating is more chunky and what becomes smaller that might be sinking out as well.
Yeah, that has a lot to do with biofouling. So like as organisms grow on the plastics. In fact, Woods Hole describes it as maybe a yo-yo effect. So as they sink, because more stuff is growing on them, causing them to sink. And then once they hit past the photic zone, so it's darkness, then those organisms die and then they surface back up. There's so many dynamics to the issues with plastics. It's even hard to gauge how much is out there because it depends on currents and high pressure systems and where you are at the right time. So, and that picture, or those pictures that I shared of the chunky, it's really important to note that that is not what the entire ocean looks like. This is, dragging a surface sampler for about an hour, still very damning, but there's time, and we do have time. And I don't want to send like a message that the entire ocean looks that way, because it doesn't. In some cases, it looks worse. In some places, it looks better. And then given a certain day, it could be worse in one location, and then the next day it moves on to somewhere else. So, you know, like the whole idea of cleaning up the ocean by dragging nets, you know, is just a really bad idea. And it really is about just stopping using so much and doing cleanups. You know, people say, why bother cleaning up? It's just going to be there again tomorrow, right? But the work that Scott's doing, you know, no, it is actually the best ocean cleanup we have is when we pick up this trash. And if sometimes the nature, because the ocean will, you know, push back dead stuff onto the beach, sometimes we get a second shot at grabbing it. So I encourage everyone, and I know everyone that's on this call probably does already, but get involved in cleanups, do as much as you can to help pick up as well as reduce your use. And we're going to get there much faster the more people we get involved in doing so.
And buy recycled.
And buy recycled content, you know, that's such a good one, Nina. You know, I usually present, you know, that's one of my part of my talk. You know, I'll say to people, how many of you recycle? And the hands go up. And I'm like, how many of you actually look for packaging that's made out of recycled material? And there's maybe one.
Yeah, when I was just moving from California to North Carolina in 2004, I was on the board of the Northern California Recycling Association, and we produced a movie called Point of Return, not Point of No Return, Point of Return. And it was way before National Sword or the Green Fence, but we were shipping, I could see this growth happening of how much more was going overseas, and it was hurting our domestic recyclers. And, you know, there was demand for it to offset, you know, there's insatiable demand from China, and the container ships are going back empty. But the point of it was to look at how do we really level the playing field and handle our things more locally, handle our own stuff. And I was trying to push the message of just putting it at the curb is not recycling. And we've lost that. I think it's been out of our zeitgeist. The National Recycling Coalition, way back in the day, kind of before I really got into recycling, had a whole buy recycle business line. So it was, you know, thousands of businesses, millions of dollars, really pushing the concept of, but this is in conflict with our basic consumption-based model. So.
Scott, were you going to weigh in on that one too?
You know, I was going to just add on to what Bonnie said about the need to get out and do these cleanups. And, you know, one thing that troubles me is there seems to be a lot more emphasis put on preventive measures, which is absolutely important. We have to do that. We have to move quickly on that. We have to reduce consumption. We have to prevent materials from getting in the ocean in the first place. But I think it's equally important that we get out and we clean up now while the materials are intact, because, you know, as you leave these materials in the environment for longer and longer periods of time, it becomes more and more difficult. So, for example, I mean, this was made really aware to me when I got into it, is, you know, when you go and pick up a 5-gallon bucket that's only been out there for a year or two, or maybe a few years, it's 2 seconds to pick it up and you've collected 2 pounds of material. But if you let it sit there for 10 or 12 years, when you go to touch it, it shatters into a million pieces. And now you've got an hour to try to collect as many of those pieces as you can. And you're not going to be able to do that. You know, it's just physically impossible to clean up all the microplastics. So capturing them while they're intact and capturing them now will allow us to clean up the environment. And once they break down, they're so much easier to get ingested and enter the environment in much more destructive ways than if they're, you know, intact.
Yeah, and I'd like to add to that. So there's actually research that supports that, you know, while those plastics are sitting out in the sun, they're actually releasing methane. So as we know, when we, you know, melt plastics, it's releasing methane. Well, it's happening when it's exposed to UV light and heat. So as we leave those plastics out there, we're actually then contributing to climate change. Now, we don't know to what degree, but if we can figure out ways to reduce climate change, that's another way that we might want to consider.
Okay, Bonnie, there's a technical question for you from Anna Lewis, and I'm going to try not to butcher this one. How do you plan to conduct a full plastic additive screen on the fuel byproducts? I see those common suspects, PAHs, toluene, etc., but I wonder about PFASs that might actually have survivability and concerning degradation products. I'm not sure sulfonated PFASs might be a source of sulfur.
Yeah, I mean, that's such a great question. And I never thought, and this is what's beautiful about having these, you know, meetings, is that we always learn something. We all get to take something home with us. And I know everybody on this panel is taking stuff home. And that is a good one. You know, that's one area I would love to study more, is about the PFAS and plastics, as well as Gen X. You know, does it adsorb onto these plastics that are in our rivers that are heading out to sea? There's, you know, as we drill down, there's more and more we can learn. But the whole point of me starting Plastic Ocean Project was recognizing the fact that our EPA really is defunct. I mean, they do some really great research, but if the legislation side isn't doing their job, and that because they're strapped politically, then we really don't have anyone looking out for us. So this is why I started this nonprofit, so that we can help be a watch group, or at least an independent lab, so that we can explore these questions, so that someone could come to us and say, hey, we got a question we'd like to try to answer. Then we can try to find grant money or people that have money that want to support such research. And we start educating people so that they can make better choices. And that's really where we have to be. And what Nina does is exactly what she's doing. She's educating both sides. You know, she's working with industry, and then she's working with the masses, and trying to really carve out that path that best satisfies all the needs on both sides. So.
Okay, we've got a couple more questions come in. Do you have any tips for buying products that are truly recycled? I know that greenwashing is alive and well, and so I have a lot of doubts when I see recycled products.
Yeah, let me share my screen real quick, but I'll also share this in the chat. So we've built this tool that we still just make free and are not funded to keep it, but we felt like there was a need for this transparency. So we created this biorecycled performance meter, and we have our protocols. You can click here to learn more of how we list companies. So it's not a pay to play, but they have to tell us either they're third party certified, they give us their certification, or who they're getting their feedstock from. But and so we're trying to monitor it as well as we can. But it's how much recycled content, what resin, is it multi-material, and is it third party certified? We're going to be hopefully adding some new features like search capabilities, click through to purchase, but there's a lot of products in here for the public. And then we also have one for businesses. So, you know, as you're trying to integrate work in process recycled content. So I encourage you guys to check this out as well and share it. We'll be sharing more of this as we ramp up to provide education on the actions for circularity. So get in touch with me if you would like to help.
That's a great resource, thanks.
Yeah, Nina, I had no idea. That's really awesome. I'll use that tool for sure.
There's also a lot of opportunities just to reuse materials that you have at home, you know. So I know my go-to container for storage now are Talenti ice cream containers, which is a PET 1 pint container, and they work great. And just, you know, taking those opportunities to see, like, where am I creating waste? Because recycling is great, but, you know, if you can avoid having to recycle and just reuse it, you know, 100 times, then you've made a much bigger impact. So looking for those opportunities to reduce waste and reuse.
There's an organization called Upstream, and they have an information hub, and I think they're building a decision tool to support more reuse and design for durability as well. And that we want to, as we have circularity in action is for all materials, really focus on recycling right now, but the future is to extend to reuse. And again, how do you make those trade-offs depending on, it's one thing if you're shipping it really long distances and are refrigerated versus if it's more local. And my real passion these days is about regenerative agriculture and composting. But we've got to look at it through all those different lenses, and it's complex.
There's a question that I really love that I want to end on, and then Lisa has something that is even more positive that I want to end on. I had a question about capacity for technologies to replace Virgin, but that's boring. I want to end on something, not boring, it's actually interesting, but it's not as hopeful and exciting as the question about, from Emily Roberts, what gives you all hope that we might be able to reduce consumption?
Well, I'll start with one. I was on a webinar about a week ago, and it was to address the plastic fiber issue. And it was a bit of an X prize, so it's $650,000 for anyone that can come up with ways to work around the plastic fibers. And they were saying that we are turning the corner where now industry is really hungry for some solutions. And they gave this, you know, like $1 billion. It's out there just waiting for these new technologies to emerge. And some of the ideas were, you know, tapping into indigenous or native people to see what kind of fibers did they use. And of course, you know, addressing, like Nina was saying, instead of like shipping things across the ocean, what do you have in your community that you can utilize? So for example, in North Carolina, we're in the perfect place to grow hemp. And so, you know, making hemp fiber so we can make clothing or shoes or whatever. And then, you know, if you're somewhere else, you're doing sugarcane, you know, maybe you're using that product, the fibers from sugarcane to make a product. So I think there's going to be a lot of upcoming solutions to shift away from just everything being plastic. That's not to say to get rid of it, but that gave me so much hope. Hearing these beautiful people talk about really solid solutions, and that there's money out there, that there's actually corporations that are saying, bring on the solutions. We're ready now. And they hadn't been. So that's hopeful.
Yeah, that's great. I'd have to say, first of all, thank you for asking that question. I saw it come up in the chat, and I was hoping we would cover that one, because there is an area for hope a bit, and to me, it's growing every day. I noticed from like a small scale where I get calls all the time from people that want to make a better decision, and I don't always have the answer, but at least they're asking the questions about, you know, what should I use? I'm having a party and I want to have takeout containers to take stuff home. Like, what do I use, and how do I make those decisions? But also that's growing to where brand owners and packaging producers are recognizing that people are concerned about this, and that's why we have so many companies now committing to having recycled content and making their packages recyclable and signing on to the Ellen MacArthur Foundation's commitments. And so, you know, that the small voices have all added together and have really made the industry shift. And I think that's what gives me hope.
Yeah, I would absolutely echo that. Today before the call, I had 2 calls with companies looking at, well, what exists now and what will be in the future, and how do we prepare for that shift? There's a lot of opportunity. I think Bonnie's words were, have we even given them a chance yet? But we always have to put it back in the context of at scale and what are the trade-offs. And there's a podcast and group, the Bioneers, and also biomimicry. I think, yeah, looking back to what's the wisdom within indigenous cultures? How can we be inspired by nature, and how do we work in a more collaborative way? I think there's a new era of business opportunity opening up and a paradigm shift, and that is ultimately what gives me hope right now.
That was a wonderful way to end this panel, and that is really encouraging and inspiring. And Lisa, if you are ready with maybe the next generation of people who will inspire us every day.
Yeah, sure. So for those of you that joined us during the break, right before we started this panel session, I think you know what I'm talking about. We're getting ready to give a little special thank you to our panelists by a little music ditty. So if you would please unmute yourself, I will give you just a couple of seconds to do so, and hopefully you can join in with this.
Work hard, save
save
the
the
planet.
planet.
No
No
pollution
pollution
around
around the world.
Make sure
Make
you
sure your plastic
gets
has a
a
home
before
before the streams
takes
it
it
away.
away.
Yay. That's for you, Nina.
Thank you. That's my youngest daughter. I actually played that at the Global Plastic Summit in front of hundreds of folks in petrochem and plastic. And I think it was like the perfect little set of words. Find a home for it before the streams take it away. And she completely wrote that. Yeah.
Well, it's absolutely brilliant. Thank you so much, panelists. Please feel free to continue the chat during our break. Folks that are joining us through the chat, you can also join in and unmute yourself, or join in via video and unmute yourself during our break. We will be getting back on schedule right at 2 o'clock. And thank you so much. Thanks, Heather. And biology break time.